Good morning. Amardeep Banerjee, my name, the Innovation Manager at EIT Manufacturing. A warm welcome to all to the third webinar series of the Co-Versatile project. And I'm happy that we have high numbers today, and I would like to walk you through the agenda for the webinar series today. So we start on time at 10. We would do a welcome and an introduction of the project to those who are new to the project, in terms of what is it about, and also what is the bigger goal. Then we start with the first speakers, where we have the first work package, or the manufacturing setting, we call it. It's about reusable silicon mask design, and we have esteemed group of 3 speakers there who would be coming from industry and research background. This would be followed by a talk from on electrostatic disinfection sprays. We would have the colleagues from Spain joining it for this one. And then the last one before the break would be from Netherlands. Medical ventilators would be the topic. And at 11:10, we would do a short break of 10 minutes. This would be the time for you to reach out to the speakers. You could also take a coffee break. And all the bios of the speakers is available on the Hopin platform. And and the last, I would say the last 2 slots for speaking after the break. One of them it's from the B2C. Now we go to a B2B aspect, where we are talking about flexible machines for face masks production in Europe. A very interesting topic. The speaker is from Netherlands. And the last one would be about manufacturing repurposing with a robotic cell. We have colleagues from UK joining for this one. And as you see, this is a pan-European project, and I'm happy to be moderating the session for today. And housekeeping note, please write your questions during the pitch, or during the sessions in the Q&A, or in the questions or comments section. We would either take it right after the session or the webinar, or we would take individually after each say speaker. This is something which we can decide based on the time, but I would really appreciate if you could ping your questions, be active, and at the same time have fun for the next 2 hours. And so next slide, please. So a bit of background. What is the Co-Versatile project about? Why has it started? So basically, it's one of the 4 EU coronavirus call for repurposing of manufacturing for vital medical supplies and equipment. So basically, there are 4 projects in approximately around 22 million euros has been funded or granted by the EU. And Co-Versatile is one of the 4, so that the other 3 are Eurodry-K, Reservist, and Impure. If there are questions on that one, feel free to reach out to us later. Co-Versatile mainly is about adaptive and resilient production and supply chain methods and solutions for urgent need for medical supplies and equipment. A little bit more about Co-Versatile on the next slide. As I said, this is really a remarkable pan-European effort. We have colleagues from 21 members joining from Austria to UK to Israel, Italy, Netherlands, and Spain, and Switzerland as well. The coordinator is from Hungary, Institute for Computer Science and Control. The budget is right now 6.27 million euros. The duration of the project is 2 years, although the project has started 4 months before the start. So technically, it has been a little bit more than 2 years. So we have started officially on 1st of November 2020, and right now we are on 2nd of December 21. So we are almost one year done with the project, and so we have some results which we would like to show today in the form of the webinar. Next slide, please. Yeah, a quick reminder. As I said, this is one of the 4 webinars we have. The next one is on 9th of December, which is related to workforce ramp-up. Today, we would be focusing on scale-up of production, and we basically have a very interesting lineup of speakers for that. So this is a reminder. So bookmark your calendars. Make sure you're there next Thursday as well. And yes, and so what is basically, if you dig deeper, what is it about? So basically, we talk about 3 main pillars for the project. One of them being adapt manufacturing process for upscaling of production. Then so basically it's also very interesting not only for medical supplies, it could be interesting for example, automotive or aerospace as well. The second pillar, which is the focus for today, reconfiguring and re-evaluating industrial supply chains, is a topic which is growing of very high importance. And sorry. And and the third pillar is workforce ramp up. This would be the focus for the next Thursday. So for now, we're talking about reconfiguring and reevaluating basically how, if it makes sense and how feasible it is to produce locally for the local customers, especially in a case of a pandemic or an extreme supply situation. So this is what we have as the overarching theme for today. And it is a very, very relevant or a valid industrial challenge. So we are not only talking about, I would say, moonshot ideas, but this is a challenge which is faced by the society today, and we need to solve it. So we would like to go to the next slide, please. We would like to introduce our first speaker for today. So the next the first speaker is basically, we have one manufacturing setting or one group who would be presenting together or one after another. So we have Silvia Lodetti, who is the communication manager at ML Engraving. Silvia is in charge of the communications department of ML Engraving. It is an Italian company and provides high quality services of laser engraving and laser texturing. She has a master's degree in philosophy from the University of Milano. The second speaker, which would be followed by Silvia, is Yuval Erez. He's the co-CEO and managing director of SKM Aeronautics, a boutique manufacturer of precision rubber and silicon pads for the aviation, military, and defense and medical industries. And with the Co-Versatile project, his organization is involved at the development of the process to be implemented at emergency periods. And we have Dr. Matthias Wagenheim, who is the Assistant Director at the Institute of Dynamics and Vibrations Research at Leibniz University, Hanover. And he's leading a research group in the field of friction and tribology. So Matthias has been involved in several Horizon 20 and Horizon Europe R&D projects, and also has participated in numerous bilateral product-oriented collaborations. So basically, we would have Silvia, Yuval, and Matthias presenting the first topic, which is about silicon mask. And I would now like to invite Silvia on stage. Yes, Silvia, how are you? Silvia, how do you feel today?
I'm a bit nervous, honestly, but I'm willing to present our experience today to the audience.
Definitely. So the floor is yours. And you have 10 minutes. And if you have questions for Silvia during her talk, please feel free to put it in the chat. And all the best to you, Silvia.
Thank you, Amardeep. Good morning, everyone. First of all, my name is Silvia, and today I would like to give you a general framework to look at our project. You can turn the first slide, please. I would like also to remind to everyone, what does it mean to be ready to face an emergency? So, next slide, please. I work for ML Engraving, as Amardeep has said, and we are partner of the Co-Versatile project. And we are an Italian company, and we live and work very close to Bergamo. And if you remember, Bergamo was the first and most affected area of Italy where coronavirus spread back in March 2020. Next slide. At the time, all of a sudden, we were under attack. We didn't know what to do, but around us, friends, relatives, people we knew were getting ill, or even dying. We had no guidelines, no protocols, no devices, and we had the highest ever death rate for our local area, something really heartbreaking and unbelievable. Next slide, please. Hospitals were out of control. Intensive care units were full and they couldn't afford the amount of patients arriving every day. And the most dramatic situation is that vital equipment was missing. CPAP devices weren't enough for the many patients who needed oxygen assistance. Next slide. But then an Italian company called EasyNova designed special fittings, the yellow ones that you see, that basically connected common snorkeling masks to oxygen dispenser. And so they created emergency CPAPs. And those fittings were made out of additive manufacturing in order to save time. And files were available for free on the website of EasyNova. And in just a few hours, people started downloading and producing the valves. Next. And so in ML Engraving, we did the same. We started to produce our valves, but we did something more. We tried to build a sort of micro supply chain in order to boost everyone's efforts to this project. And this micro supply chain included the testing of the files, the coordination of the suppliers, more than 50 3D makers who worked extremely hard. We managed the logistics with the civil guard because we were in lockdown, so we couldn't drive. We did the quality control, the assembly, and also the reporting to give feedbacks in order to improve the production. Next. So the result is that even in the most dramatic time of our lives, together as a group, we were able to provide our local hospital with more than 200 complete emergency CPAPs. And together, we were able to help saving lives. That's what matters. Next. Those are just images of our production line we built in our facility. And next, my conclusion is that yes, this is a story of a tragedy, but also a story of resilience and hope. And what we learned is that even if we witnessed the tragedy of not being prepared enough, we also discovered the power of getting together, networking, coordination, and of course, prevention. And that's why we, as ML Engraving, joined the CoVersatile project with the aim to share and scale up this experience. So now I'm introducing my colleague, my partner Yuval from SKM Aeronautics, and I thank you very, very much for your attention.
Hello, my name is Yuval Erez. In the next moments, I will speak about real-life examples of rapid response manufacturing and repurposing of production lines during COVID-19 pandemic. So a few words about us. We at SKM are manufacturers with over 60 years of experience in the rubber industry. We specialize at manufacturing precision parts from silicon and technical rubber. was certified to 3 international quality standards for manufacturing rubber parts for medical devices, aerospace, aviation, and military, as well as precision technical parts for industrial application. In fact, SKM is defined by Israel's Ministry of Defense and the Ministry of Labor as a vital factory during emergency periods. Therefore, in such cases, we continue production according to special governmental warrants. We normally serve the defense industry. However, during COVID-19, we had to quickly adjust our activities for supporting health and medical needs. So it all started with a big surprise. COVID-19 burst out in December 19. The virus was new and unmapped. The media channels reported that thousands died in China. Soon later, thousands died all over the world. Europe was also under COVID-19 attack. Like the rest of the world, Israel's health system was not ready. Private sector companies like SKM immediately joined the national efforts to fight the virus. Now, we know that the World Health Organization had no real methodologies for dealing with COVID-19 pandemic, medical-wise or industrial-wise. Hospitals did not have sufficient respiratory machines, rubber gloves, and surgical masks. Factories were not ready for immediate production of the required additional personal protection equipment. Vaccines and medicines were not available. Past pandemic events rose primitive fears. Thousands kept dying daily all over the world. People were terrified. The fear motivated immediate response solutions. Major closures and lockdowns paralyzed our economies. Face masks perceived as the primarily preventive solution. The Israeli cabinet ordered our industries to locally develop and produce high-quality preventive face masks, respiratory and oxygen systems, and local vaccines. In parallel, our health system developed fast deployment process for mass vaccination in case a vaccine would be available and approved by the FDA. So how did we fit in? In fact, SKM had to quickly repurpose its engineering team and production force, including our production line, with priority to COVID-19 solution at 3 different efforts. The first effort focused on governmental and defense industries, which together worked on local solutions for manufacturing of additional respiratory systems. In this effort, SKM developed and produced thousands of silicone diaphragms and bonded valves for respiratory and oxygen systems. The second effort focused on private sector companies, which separately develop personal protection equipment. In this effort, SKM developed and produced over 150,000 filter seals for professional face masks for medical rescue teams, brand name VeriMask. Also, SKM designed a transparent face mask for handicaps. And the third effort focused on the European Union's programs. SKM joined the CoVersatile project for developing low-cost, fast deployment silicone mask. Together with our CoVersatile partners, we answered a call for adaptive and resilient production and supply chain methods and solutions for urgent need of vital medical supplies. Together, we focus on repurposing of existing production lines for the design and manufacturing of a multi-use, unified type silicone face masks, mending for fast response and local manufacturing by multiple European rubber molders. The idea is to distribute and transfer these abilities to as many rubber molders as possible. At this point, I will give the stage to our distinguished partner, Dr. Matthias Wagenheim, which will further explain the status of our project. Thank you very much.
Thank you, Yuval. Good morning, everybody. From my side, I'm Matthias Wagenheim from University of Hanover in Germany. Based on these personal impressions we just heard, I will present our activities in CoVersatile project on the reusable silicone mask design. I would like to start my presentation with an introductory poll. And I would like you to answer if you feel more protected wearing a face mask. Please answer yes or no and use the poll function of this Hopin webinar platform while I continue my presentation. In some minutes, I will discuss the results of this poll. Now, a CoVersatile project is about the rapid reconfiguration of manufacturing lines in case of emergencies. And I will use the example of a face mask, which we are working on in our group. The initial situation, if we remember, was that during the outbreak of COVID, we had a strong shortage of medical masks all over Europe. Furthermore, we were dependent on uncertain and unreliable suppliers, for example, if we talk about non-woven filters. And in consequence, this led to a long reconfiguration of European factories that we are able to produce our products for ourselves and are not dependent on others. The vision now in our project of our group is that we at first create a widely accepted product, our face mask. We need a versatile manufacturing concept so that we can enable European manufacturers to build our face mask as well. And we need to train and prepare them well to reconfigure their production lines to adapt our technology, our molding technology, and our masks. In such a big European project, we have the advantage of a great intersectoral and interdisciplinary team. The core activities of our masked project are the manufacturing sites. This is the mold maker ORP in Italy. This is the laser engraving company ML Engraving in Italy as well, and our molded parts manufacturer partner SKM in Israel, which you just heard. We work together with R&D engineering support concerning process simulations in Spain at ITA Innova and rapid prototyping at our university in Hanover, Germany. We had some business consultancy from some partners, especially concerning the topic certification by the University of Applied Science in southern Switzerland, SUPSI, by the company HSSMI in the UK concerning training activities. We analyzed our supply chain at Fraunhofer IML in Germany and did a risk analysis of our activities at IE Business School in Spain. Now, if we talk about the mask design and if you ask customers what is important about the mask design, then first of all, you will hear wearing comfort. And wearing comfort, especially in context with rubber mask, is not only the pressure on your face, which you feel, and the forces, but also the texture. So velvety texture was mentioned there. Concerning comfort, we also heard the ease of breathing is important, of course, and no fog on glasses. And transparent is an important issue because then, or important advantage, because then we can see the mouth moving while talking and see facial expressions. Another topic mentioned was sustainability. So if we could create a reusable mask, a washable mask, even with exchangeable filters, this would be a great plus. So based on these requirements, we started our mask development. At first, we discussed the material. We would go for silicon elastomers, HCR, because they are available in medical grades, they are good to process, and they are non-toxic. Although, of course, they create a waste, it is non-toxic waste and the best what we could think of in this situation. Another investigation we did on the filters. We checked cloth filters and non-woven filters in different filter classes. We finally decided to go for non-woven filters because, first of all, they are structurally stable if you put them in front of your mask, and they are even compostable. Transparency was an important topic for us there we required some simulation support. The transparency of silicon rubber is defined by two main things. One is the wall thickness. The thicker, the less transparent, of course. And secondly, the filling quality. So we made simulations on filling time, on filling temperature distribution, and also we tried to identify welding lines when the flow of two material flows during the molding process come into contact and build such a line. This would is to be important for the transparency. We took advantage of rapid prototyping. We 3D printed with an SLL process a full rubber mask in a very, very early stage, even with a microtexture, so we can have a very quick impression on the contact of our rubber and our velvety texture with the face. In the real product, the texture will be put on the product during the molding process. And so we need to texture the mold. This is done by ML engraving. We need to texture free-form surface with our nanosecond laser technology. And for this topic, ML did a lot of trials with different velvet textures, like you can see on the bottom, to improve the contact with the skin. Now the mask design is defined. We go for silicon elastomers. We will use non-woven filters. It will be transparent for sure. We can take advantage of laser texturing of the mold and the insert. And we found a design to adjust the strength of our straps behind the ears. The mask is defined. Now we need a mold to produce our mask. We fit our design to a 500 by 500 square millimeters press because this is the most common press size in the rubber manufacturing world in Germany. We will make use of an insert for easy demolding. This insert will be textured, and we optimize, of course, the injection inlet positions. This type of mold will be able to work with all types of solid rubbers. We go for the transfer injection process with the great advantage that we don't need to deflash the parts. So there's no manual process of deflashing, and we can reduce our rubber waste. Concerning support activities from our partners, we made a risk analysis concerning production risk, supply chain risk, market risk, and certification risk, which might come up during product life. We analyzed our supply chain with all tier 1 and 2 suppliers, the transport risks and market demand. We discussed the certification issues concerning medical device certification, filter classes, and production quality. And we created training documents to enable technology adopters, to enable rubber manufacturers producing our mask with our technology. So where are we now? The mask design is frozen. The supply chain for the pilot line is defined, and the mold is currently manufactured. And we expect in the upcoming weeks to have the first mask in our hand. The future steps and visions we have for the second year of the project is to digitalize via the CoVersatile Digital Technopole some of our product development stages. This is in particular the supply chain analysis, the molding simulation, and training activities. We would like to give them to the public to have access via this Technopole. Technically, we will continue working on individualizing our mask design, and we would like to professionalize this rapid product design, prototyping, texturing, and mold making processes we developed, because in the next pandemic, maybe we don't need masks, we would need another product, and we would be available for that. Thank you very much for your interest.
Yuval and Matthias for sharing the highlights and also the lessons learned from the pandemic. I would say I had a quick question. In the interest of time, maybe a very quick one. What we do in case there's a shortage again for silicon masks? What could be in terms of say a short-term strategy for Europe?
Yeah, from our point of view, the advantage of this mold design is that we do not necessarily depend on these medical grade silicon rubbers. We also can go for other rubbers. For example, food grade rubbers they can be processed well with this type of molds. And in case of an emergency, it's probably more important to have a mask than to have a medical graded mask.
Yeah,
it works with all types of solid rubbers.
Okay, good. And thank you, Matthias, for that. And we would come back to you, Yuval and Sylvia, at the end when we have the panel on the Q&A. The poll is still 50-50, the question which Matthias has given to the audience. Feel free to engage further. And really appreciate your presentation today. And I wish you a good day ahead and see you later.
Thank you.
So thanks. So we stay with we continue with the theme prevention. And our next speaker is going to talk about production of electrostatic disinfection spray systems. Cristobal Rodriguez, manager at Technostatic. He has more than 30 years of experience in cleaning and hygiene sector. And since 2018, he's working and developing an equipment with electrostatic spraying technology to improve the technology of disinfecting products. So Cristobal, Sergio, I think Sergio is with us. Feel free to share your slides. You also have a very nice video, so we're looking forward to that. Yeah, I see your screen and your slides.
Okay. Good morning, everyone. Okay. I am Sergio Rodriguez from Technostatic. I am the speaker and the manager of the customer service, and Cristobal Rodriguez is the director of Technostatic. He is not going to speak here, but if someone wants to talk with him or something, and you can tell me first, and then I will share the information. Okay. Technostatic. We are a company that manufactures different models of professional high-performance electrostatic sprayers for the disinfection of our surfaces, and designed for all types of sectors. Where are we? Technostatic is located in Zaragoza, Spain, 300 kilometers from Madrid and Barcelona. And the technology is that the sprayer, as you can see, creates a spray of drops with a size of approximately 40 microns. And these drops are polarized, so with negative zinc electrical charge. These drops are attracted to the surfaces as if they were a magnet. The spraying is assisted by air, ensuring that the droplets are transported and penetrated in any area, even in those with difficult access. Our sprayers allows spraying any disinfectant based on water and spraying it on surfaces in a homogeneous form. The benefits of this technology are that the saving disinfectant product gets an uniform coverage, as you can see in the second photo, does not leave spaces without disinfecting, Thanks to the assisted air, the disinfectant can penetrate drops even in hard areas. The electrostatic charge that the droplets receive before leaving the pistol makes them act like a magnet, being attracted to the surface. And also you can get better disinfection results. After disinfection, the installation can be reused without loss of time and can be applied to electronic equipment. In the test carried out, have shown that our spraying system is stable, keeping the size of the drops, and the electrostatic charge is constant and uniform. These are the machines. Our equipment has allowed disinfection in all types of establishments during the pandemic, helping to prevent the spread of the COVID-19. One of the most outstanding customers has been the Spanish Army. Used our equipment to disinfect nursing homes and other facilities. As you can see here, all the machines that we produce and some places that we have work with. The sectors that we use. The electrostatic sprayers can be used in all sectors and installations. As you can see, the food industry, gymnasiums, hospitals, offices, schools, hotels, transport, restaurants, and the nursing homes. Suppliers and other sectors. The manufacturing of electrostatic sprayers requires a large number of components and suppliers. And with experience gained in 2020, during the pandemic and the containment state, Tecnostatic has created an emergency action plan. First of all, maintain a stock in our facilities of approximately 50 units of each reference that can meet the initial demand. Agree with all suppliers a safety of 100 units for each reference and component. Also, a production supply of 50 units. Finally, the quantities of supply will be adapted according to the evolution of demand. Each supplier and components has been validated. We have seen a contract with suppliers with penalty for non-compliance. Okay. The work and the training staff. Tecnostatic, in addition to having its own staff, has created a work team outside the company giving training and signing a commitment contract with, in case of pandemic, join our company. These people have been trained in the different production process. The commitment to join our company is verified every 6 months. Logistics and the transport. Transport is a sector that, in times of pandemic, continue providing services. Companies such as UPS, DHL, and FedEx have maintained the services with minimal incidents in order to guarantee as much as possible the logistics and ensure as much as possible the delivery of our equipment to the customers. Tecnostatic has signed with a local continental transport company for Europe a transport agreement for the countries of the European Union. The average delivery time is 24-48 hours, depending on the final destination. And that's all. Thank you for your interest. If you have any doubt, you can consult with me. And now you are going to see a video of our technology.
Perfect. So that's. I'd like to thank the team from Spain, for Cristobal and Sergio for the presentation and the video.
Thank you.
Sergio, I had maybe a quick question on the technology. I was very interested in terms of how is it compared to the traditional sprayer, and what do you do next in terms of the development of the technology?
Can you repeat, please?
Yes, the technology you have developed, which is the electrostatic spraying technology, which reduces disinfection time, as compared to a traditional sprayer, which is the other option. I think it's quite effective. So how do you continue this? Are you trying to benchmark it with the traditional sprayer? And what is your next step with the technology development?
Okay. Our next step with our technology is distribute in other parts, in other countries. The comparison between other equipments is that our electrostatic technology functions with a compressor. A normal sprayer can use a bomb that it's different technology, it's less efficient, and our sprayer use the compressor that gives more power when the air and the product that someone can use, when they mix and with the compressor air, produce a powerful exit of the product. So this is more efficient than a normal sprayer.
Okay, perfect. So thank you. So it's more efficient, more effective, and you are looking to expand to other European countries. That's very nice. So if there are questions for this group from Spain, please feel free to write in the comments. And I would also invite you, Cristobal and Sergio, in the end for the Q&A at 12. And this will be an opportunity to also take a few more questions. So really appreciate the video and the presentation today, and have a good rest of the week.
Thank you.
So, perfect. So the next speaker is Thies Rupert. He's the Managing Director of Demcon Industrial Systems. Hello, Thies.
Hello, good morning.
Good morning. And Thies would today tell us about the challenges in production process his company faced when scaling up the production of medical ventilators during the pandemic.
Yeah, but now we have a little mixing up, so that's my colleague Ben doing that talk.
Okay, so sorry for the mix-up. So I leave the floor to you for a quick introduction, and I believe you also have a question. So can we get these back on stage, please?
Sorry, Amadip, I'm having the presentation after coffee break. So my colleague Ben is doing the part before the coffee break about the ventilators.
Okay. So then let's invite the next speaker, which would be Ben.
Good morning.
Good morning, Ben. So I had the old agenda, so that's why I was sorry for that.
No problem at all.
Ben is the Chief Technology Officer, CTO of Demcon Maccavi Respiratory Systems. He has a background in systems and control engineering, and has from the Technical University of Eindhoven, and indeed as the new CTO of Demcon Maccavi Respiratory Systems, who is responsible for improving the own products of the company and developing the technology roadmap, especially covering the ventilation technology and monitoring the technology for SMEG. So Ben today will be presenting the machine for face mask production in Europe, very interesting topic. And more specifically, he would be sharing with us how to organize the development and production processes effectively when working under pressure. So the floor is yours, Ben.
Good. Amadip, thank you. I will present regarding the respiratory ventilation system. So Thijs will take care after the break regarding the face mask machine. Well, my name is Ben van der Elshout, and as Amardeep said, I'm the CTO of Demcon Makawi. I will first give a short introduction on who Demcon Makawi is. Demcon is an R&D company, mainly focusing on contract R&D. We're established in 1993 by two engineers from the Technical University in Enschede. And we grow out in the meanwhile to a company of more than 750 employees, and working in all kind of areas from high tech industry up to medical industry. Well, typically the activities of Demcon, in a nutshell, as an R&D company, we start in a lot of activities from scratch, where we really make with a customer the first ideas how a product should look like, and go via prototyping up to production, which we can facilitate. And if you practically look to what we did in the COVID situation, we did this whole process from scratch to production practically in 8 weeks, because of a high demand of the Dutch government on ventilation devices. And I will first ask to show a movie which shortly presents what we did in this time frame.
Virus is having a major impact on our society, and everyone can contribute to flattening the curve as much as possible to ensure our healthcare system is not overwhelmed. A major challenge, however, is to equip hospitals as quickly as possible with ventilators for those who desperately need care. Demcon develops and produces modules which form the heart of these machines. We have significantly stepped up production to supply manufacturers of ventilators all over the world with these modules. In addition, we have taken up the challenge to develop and build a simple, complete ventilation system based on our existing modules and years of experience. We are proud to have realized the DemCare ventilator, a new system created on a vastly accelerated timescale to meet the surging demand for these systems. With great commitment from our colleagues and heartwarming help from our partners, suppliers, and government, we have the opportunity to contribute to the global fight against this crisis.
Well, thank you for the movie. Well, I will quickly introduce the timeline from a technical perspective, how this project moved on. We started in the end of March when we were reached out from the Dutch government if we can create a system like you saw in the video. And practically what we did, I presented here in a rough time scale. 3 days before we got the official start of the project, we started with a couple of team members to make some sketches on what the system should be and how it should look like. Well, you see it in the picture overview on the slide and the top picture. And in the first 2 days, well, we finalized those sketches already. And on Monday morning, we started with a development team of 50 people, more or less, to start designing and working out how this machine should look like. And as a rough time scale, after 1 week, we had the first prototype available, which is the third picture. 1 week later, we were able to do a technical test in the hospitals. And even 1 week later, we were able to do the first clinical test on a patient. So practically, we moved our technology, which we already had, up to a complete end user product in 3 weeks, which was able to ventilate the patient. In that meanwhile, we also started with a CE exemption to get a certification on the project, and roughly after 40 days of the start of the project, we also arranged that. Well, if you look on the same side, in the same timeline, there's also a production storyline because we had to start from scratch over there as well. So roughly in day 0, we started with arranging all the resources we needed from procurement to building the facilities and everything. well, after 7 days, we had the first bill of material available for the DemCare system, and we started the day after with the procurement. And a week after the final BOM was ready, that was practically the same moment when we had the first trials with the system. And after 3 weeks, so after the acceptance of the hospitals on the final system, we started the production of 500 pieces of this system for the Dutch government. And 40 days later, the production was done, and we were ready with the project. Well, in the sketches or in the pictures in the slides, typically you see, well, we started really from scratch with an empty production site and building up our own production lines over there. Well, there were pretty some challenges to fix in that time period. Well, first of all, there was of course a big deal to source components. So how do you get everything out of the supply chain which is needed? But I think the main thing we did over there was we did not take no for an answer. We moved into the supplier processes. We will interfere with everything what happened in the supply processes to get everything out of the suppliers. We are on the design side. We used a really strong principle that you can only design what was available on stock, so that you do not have all kind of difficult design iterations. But it gave also an additional challenge because, well, we needed to be involved with our suppliers. What they were able to deliver, and if something is not able to deliver, then we needed to swap in the design, to move forward. And one thing because there are also of course a couple of non-buy components, but for example the housing parts of such a machine, they need to be manufactured. And what we did was we put our engineers really on the supplier side to discuss with the supplier in their chain, well, what is the best option to design such a housing part, for example, to get it fast on the table and to finalize the production. And there were a couple of even examples where we were not able to buy components. There's pneumatic valve here shown on the picture in the slide. That part came from the Far East. And that supplier was not able to deliver, for example, those parts in time. And what we did over there was, well, we really decided to create our own. So we made a replica of this thing, and we joined in with a couple of suppliers here in the Netherlands, and we produced our own valve for this. So everything was done to get everything out of the chain. Well, on the staffing and training side, there was also a lot of challenges to tackle. Because we needed to ramp up for the production of the DemCare system. And we also needed to ramp up for the production of our respiratory module, which is the main engine which is used in the DemCare system. Well, we had the lucky situation that we have a big company with a lot of personnel available, and that we are also privately owned. And that also the owner gave us the flexibility to shift with people wherever we needed them. So that backbone of owned people, it helped us enormously in setting up those production lines. And we were even able to get a couple of old employees back from which worked at Demcon already. So they were into the processes of Demcon and they can help us really quickly. Furthermore, typically on the operator side on those production lines, we were able to hire, let's say, high qualified personnel, which practically was too high qualified. But they were able to, well, as a quick starter to really help us in the production and scaling it up. On the space and the tooling side, we were again in a kind of lucky situation that we had two new locations of our offices, one in Eindhoven and one in Enschede, which were just delivered. And there was a lot of space available to set up our production lines over there. So in the location in Eindhoven, we started to produce the DemCare systems. So there was a complete space available, and we set up production lines over there, including end test facilities and everything what belongs to it. And in the location in Enschede, there was enough space to replicate a couple of production lines where our respiratory module was produced. And again, we were able to allocate flexible our people, which were already working at Demcon production, to help in scaling up the lines. And then I think we also had a lot of additional measures which we had to take care of due to the COVID situation, because well, we needed to keep everything running and negative, or well, yeah, negatively tested at least. And how we did that was we really physically split up the production lines and the teams. So we had multiple production teams running. They were also physically separated from each other. They did not have face-to-face transfers, so just to reduce the amount of contacts, and that we are able, that at the moment that something happens and a COVID breakout will happen in one line, that we were still able to produce in a different line. But it gave a lot of organizational effort. And also on the development side, which typically took place in Enschede, in Eindhoven, we really split the design team and the production team here. So there was one team working on the design continuously, and there was one team already preparing the production, but they have, well, practically their own canteen, their own toilets, and everything was practically separated in the building. And I think if you look back to that whole trajectory last year, I think the pandemic helped us enormously, because it was crystal clear, and I think I heard it in the other presentations as well. We had one extreme common goal. Everybody was completely dedicated, working on one machine, which gave an enormous focus, which made it happen. And also due to the pandemic, there were no motivation issues at all, because everybody knew where he was doing it for, and it helped us enormously. And everybody was also willing to help, and that everybody here, in this sense, is from a managerial level in the Demcon company, but also from supplier side, employees. Everybody was willing to help. And even a lot of companies in the close environment here, they offered their help even for free to get this whole system up and running. And here you see a little bit an overview of all the partners which helped in this whole project. So it was typically we were as a system integrator working, but we had a close cooperation with DECRA as a notified body, but also with the Ministry of Health, the hospitals, and all partners which were helping in the supply chain to get everything up and running. That was in short what we did last year during the production of the DemCare. Thank you for your interest. Are there any questions?
Thank you, Ben, for the presentation and sharing the insights from the pandemic. For me, what caught my eye definitely was this one slide, the pandemic helped, and the motivation aspects. Could you tell us more in terms of it was pandemic or the crisis which brought the ecosystem together, and there was a certain purpose. So what would it require in the future when the pandemic gets over? How can we kind of give more incentives or purpose to the whole ecosystem to collaborate and come together?
Yeah, it's a good question. It's also a question where we thought about last month as well, because typically due to the pandemic, you saw that all lines were really short. So communicating was not via email with long lead times. Everything was just, pick up the phone and organize what you need to organize. To be honest, I think that it will not work anymore like that at the moment, because at that crisis situation, everybody had the same sense of urgency, and was willing to help and cooperate in this sense. But it was special because everybody parked his regular business and jumped into this kind of activities, which is, I think, in a realistic situation or in a non-crisis situation, not feasible anymore. Although we also think internally, what did we learn from that, and can we somehow use some principles which we used during that crisis situation also in the current situation. So for example, keeping focus and use those short lines. It's something we still try to practice at least. So typically we are an organization which works in projects, and working in projects sometimes means that all your employees are a little bit scattered on their activities, and we try to also compact that a little bit so that everybody has more focus on his own, a longer focus on one specific topic.
Yeah, fascinating. And following on that, my impression was also there were these two greenfield projects in Twente and in Schede. So how was their experience in terms of the greenfield or ramping up of production? What lessons could you share to the audience in terms of, say, how could one ensure the right quality level when ramping up production? And because this is often a problem, especially in the new products.
Yeah, the thing was with the in Enschede, where we produced and still produce, by the way, our respiratory module, we had already one line available, and we only had to duplicate that line a couple of times. The nice thing was that we built those lines ourselves, so we designed and produced our end-test tooling and everything. So we were also there in charge of our own, about the quality which we deliver over there. We were not specifically dependent on external parties, and typically, we are a production company which is already extremely used in the medical area. So our quality departments and everything, they also took a look in how that ramping up goes. And the same a little bit in a different flavor went to the location in Eindhoven where we produced a DEM care system. We were also there able to produce our own end test lines and everything what belongs to that with the same quality system behind it.
Okay, makes sense. Yeah, thank you, Ben. So I would ask or request the audience, if there are questions for DEMCON, please feel free to put in the comments. At the same time, we would have a Q&A with the whole group of speakers today at 12. So we could take your questions there or also in the chat. And really appreciate the presentation, Ben. After now, we would have a short break of 15 minutes. So we would start approximately at 11:20. So it's a little bit more than 15 minutes. And following the break, we would have we would be continuing with DEMCON, and we would have Thies joining us. So after the break. So right now, please feel free to take a coffee break, a bio break, answer your emails. At the same time, it's an opportunity for you to reach out to the speakers, reach out to the wider audience who is participating in the Hopin platform today. There's a functionality to book a meeting, a functionality also to put a chat, and feel free to explore. So I wish you a good short break and see you at 11:20. Welcome back to the second session of our third webinar of the Coversatile project. Before the break, we had a very interesting group of speakers presenting about silicone masks, medical ventilators, and disinfection spray machines. And we have the pleasure now to invite our next speaker for today, who's the Managing Director of DEMCON. I'd like to invite Thies Rupert. Thies, I hope I pronounced your name correctly.
Yeah, it's actually Thijs.
Thijs, okay.
Thijs.
Sorry, Thijs.
No problem.
So Thijs is the Managing Director of DEMCON Industrial Systems in Schede, Netherlands. And he is going to talk today about the machines for face mask production in Europe, and more specifically, how to organize the development and production processes part. So, Thijs, the floor is yours. And,
Thank you, Amardeep. Thank you for the introduction. So, hello everybody. My name is Thijs Rupert. I'm a managing director of Demcon Industrial Systems, another part of Demcon, of the Demcon group, the same group of companies where my colleague Ben also introduced just before the break, Demcon Maccabi Respiratory Systems. So our part of the company is doing development in the industrial systems market, and as such we also got involved in this project, taking the initiative for developing a machine for face mask production during the COVID pandemic. So I'm going to talk a little bit about what Demcon Industrial Systems is doing, introduce ourselves, and then give you a quick introduction to the design of the mouth mask machine that we developed. And I will explain the development process in the crisis situation in 3 major steps. So doing a state-of-the-art analysis of the existing technology nowadays, have a clear definition of specifications and conceptual choices that have to be made to really get the process accelerated. And then finding also strategic partners, which I think is very important to do, to get everybody involved in developing this specific technology, and also ensuring that you have the right materials at hand. So I will conclude with our lessons learned so far in the project. So first of all, introducing Demcon Industrial Systems. We are a partner for production technology. We like to develop and create innovative production technology for the manufacturing industry. A very broad palette of customers that we have, but we're mainly focusing on the medtech market segments, batteries and new energy, which is also, of course, a quickly emerging market, and automotive and smart production. So we have all kind of project experiences, including high precision assembly, machine systems, end-of-line testing systems, bespoke machinery, and such. Complete production pilot lines we can develop and make. So we're part of the Demcon group, as said, and consisting of 3 independent Demcon Industrial Systems companies at different locations in the Netherlands and also in Germany. So we develop our machines and technology according to this V model. That's actually also the backbone of a quality system. So we ensure this way that we develop according to a structured approach. And this methodology is well known to all of our teams, also across different locations. So we all tend to work the same way. And this keeps us also agile, while everybody is aware of the same methodology while developing a new technology according to this process. So using the model is not a goal on itself, but it's a method to do so and to be all aligned. Before I show a movie of the design of our face mask machine, maybe it's good to introduce why we started this. Of course, at the beginning of the pandemic, we suddenly realized that how depending we are in Europe to be depending on supplies, mostly foreign supplies for these typical face masks outside of Europe being produced. And we took up the initiative to develop a face mask machine ourselves. Within Demcon, having the right competences in engineering available, and we cleared our capacity, so to say, to make this machine development possible. This is now a movie showing the design as we have it right now of our own face mask machine. So it's an animation. It doesn't contain any sound, so I will do the voiceover myself. And what you will see is the different modules of the machine, a different functionality. I'll come to that later in a little bit more detail. What highlights is that we have a kind of modular setup of the machine broken down into pieces that all have the same platform size, but all host different functionality of the machine sequentially. So we see all the functions that come into play when you make a face mask in these modules. This is the final station. So just in a second, we will see the complete overview of the machine, which is actually the cascade of all these modules together. Popping up, so we get the overview with all the different functionalities of the machine included. I think this gives a nice impression of the design so far. and I will move on to my next slide. So starting this project, we needed to take a quick deep dive into what's the state of the art about face masks, about also regulatory affairs regarding classifications of these face masks, and we defined that we wanted to make a machine for production of FFP2 classified face masks. It's very important that we had a clear definition of what we wanted to produce, also to get the development of the machine quickly going. And actually, we needed to design freeze the functionality of the machine before we could continue. So what's important here is that we really got to know a lot of specific information about face masks all of a sudden when we started the project. So how does a face mask or production of a face mask work? So these are the steps involved when developing or producing actually a face mask. You supply the filtering materials. You supply a metal nose strip and apply another layer of materials. Then we do the lamination and the welding of the contour. We apply the strap, which in this case is a headband, so it's a head loop instead of an ear loop, which you see a lot in face masks. It's an important design choice that we decided for a head loop. And then the material itself is folded in step 6. And again, a welding step takes place where we close the contour while welding the seam at the top side here. And then we can cut out the mask from the material. And we dispose the waste in the material and we get the product out feed. That's actually basically how the process works. So this is not new technology here. Face masks are being produced for years and years in this way, but we have to really get to understand how these machines work in a rapid way. And we noticed that there's really a lot to find there on the internet. Actually, all kind of concepts were to be found. And we took a close look and got a lot of domain knowledge in the field of face mask production. And based on that, we took all this information to us and made our choices around our own concept for the machine. And it's also essential that machine safety, of course, is involved. When we want to produce in the European Union, we have to comply to the European regulations that apply, and mainly with being the machine directive. So also ensuring that we have a safe machine concept in the end. So what we then did was really understand most of the critical process steps that are involved in these machines and translate that into the right concept for our machine. So there is, as I said, a lot of detailed information to be found on the internet, also both in models that you can download either or YouTube movies that you can find of existing production lines. And we, as I said, we didn't copy this as such, but we took all the information to us to do a really quick state-of-the-art analysis on the technology nowadays and to translate that into our own concept that we could produce in a rapid way. So actually, this is a schematic breakdown of the system. We see the processes that apply to make the mouth mask. This process starts at the right-hand side of the slide, so where we feed in the material through a rolling system, and that is actually a continuous part of the process. So what we need here is a kind of buffer functionality to let this part of the process on the right-hand side, so the feed-in, be continuous, and the rest of the process being discontinuous. And that has a reason. So by making the rest of the machine a discontinuous process, so the material flows through and comes to a standstill where we do an application or a certain process and then move on. That in that way you do not have to move all your equipment up and down because it's a continuous running machine. So what has real focus is applying the head strap, which is really a strong conceptual function included in the machine to make these head straps instead of ear loops. That means that you have to cross the material from the one side to the other, and we've really been working on a concept to let that run in our machine. Come to that a little later. And also by defining these different modules, we were able to put a team with dedicated people in every module, so we can really do a good concurrent engineering. So coming to my next slide, which is then about the specific concept for the head strap application. So that is a concept we completely developed ourselves from scratch, actually, because we had to make this head loop instead of ear loops. So having the headband, the band of the mask behind your head and around your head instead of behind the ears. Still, it had to be quick and robust within the cycle time of the machine. So we really worked on a concept there to make that work. And this is special attention to these details that makes it key to get a working principle in the end and to bring that to a success. This slide is about partnership. So I think it's important to get partners involved to supply with knowledge, hardware, or even modular solutions for parts of the machine, where that enables you to have more focus on other specific things, and also altogether brings you makes it able to develop the machine in a quicker way. So we did really an early stage team up with other partners that we know, and develop and really have focus on what needed to develop ourselves and what we wanted to do with partners. So examples of that for our case were definitely the material infeed. So it had infeed rollers. All the functionality included here is also found in machinery that, for example, can do industrial lamination of materials. So there are definitely specialists on that topic. And we also had worked with a company before that could do part of this job. So we teamed up with them. Another part was the ultrasonic welding, which is also a very specific equipment to integrate, and also to have knowledge about how these typically non-woven materials do weld or do not weld. So what's critical there and how to set the equipment. We all teamed up with a good supplier there also from the Netherlands, which came over several times for us to bring us up to speed there. Another part is the material cutting. So at the end of the process, when we have created the mask, it's still in line of the, let's say, the strap of material, and you really have to cut it out. And you need a dedicated knife for that with a pattern, and that's also something we teamed up for with a supplier. So yeah, these are pieces of the puzzle coming together when doing this rapid development of a machine. So I think also good to mention, we worked in this project with some other partners of the Coversatile. So the company of Staki supplied us a production simulation for the machine as we have it right now. So with all the process steps, we can do a simulation on the throughput time of the mask. Another thing is that we got from HSSMI an interactive manual with a 3D representation of the machine to instruct operators in a quick way how the machine works and how it looks like and how to handle things. So, yeah, summary of our lessons learned is that important is to start with a good state-of-the-art analysis, and I must say there was very much to find on the internet those days, and still looking at YouTube or platforms like GrabCAD to see how other concepts work, and as said, not to copy that as such, but to take a close look at what is already there and make up your mind and work from that experience. Yeah, getting a clear definition on specs and concepts and enables you to have a modular system architecture with clear definitions for hardware and software, so we can really work concurrently with the development team, which is multidisciplinary, and yeah, it really speeds up the process to do things in parallel rather than sequentially. And a final point is the partnership that we had in the project and still have is a really early stage deciding what you do yourself and what you will source or what you will develop with others. Yeah, also to be preferred is technology that's already existing and proven rather than having new developments. So that's also an important lesson learned here. Yeah, and as said, define clear interfaces to work simultaneously. So do really concurrent engineering. I think that's the most important lessons learned here so far that I wanted to share today. I think this would be my last slide. So I will thank you for your interest, and I'm open to any questions if you like.
Thank you, Thijs, for a very interesting presentation and also sharing the lessons learned. I think if you have questions for Thijs, please feel free to put in the chat. You had a poll and the audience is split. Half of them say we should produce more domestically, and half of them are tending to own some material supply base. I would ask, what's your preference or what's your choice?
Yeah, I think that we became aware during the pandemic that we're really depending. So the Netherlands is also a small country, and we really are sourcing in a lot of materials and processes from abroad. So I think the lesson learned during the first critical period was that we're really depending there, and we should really take a closer look for the future to what we can produce and what we want to ensure to produce domestically. To avoid any shortages in supply later on when something like this happens again, or when new waves of this pandemic might come. So definitely, I think that the reshoring of production to Europe as such is something that we will see more in the industry, because we have to be more independent from the global market that is there right now.
True. Yeah, indeed. Thank you for that. And in the interest of time, I had actually a few more questions for you, but in the interest of time, I would maybe have the questions with you at the end after this next speaker.
Yeah, no problem.
So I really appreciate your presentation today, and I'd like to invite our next speaker for today from UK. We have two experts, or two subject matter experts from the Manufacturing Technology Center, who would be sharing first results. Mike Wilson, Chief Automation Officer at MTC. He has more than 35 years of experience in application of automation to manufacturing across a wide range of industries. And Anas Alababi, sorry Anas if I
Alababi. Yeah, that's it.
Yeah, as a senior research engineer within the Department of Automation, Mechatronics and Electronics Manufacturing at MTC in Coventry in UK. And he has more than 9 years of experience in industrial automation. So it's a very interesting project or manufacturing setting they're working on, basically about manufacturing repurposing with a robotic cell. How can be innovation driven in manufacturing to fight the pandemic and future crisis? So Mike and Anas, the floor is yours.
Thank you, and good morning, everybody. If you could move on to the next slide, Anas, that would be appreciated. So we're going to talk about trying to develop automation systems that are resilient and adaptable to accommodate quick changes within manufacturing processes. If you could move on to the next one, Anas. So just to give you a brief overview of the agenda, we'll start with a brief introduction to the MTC, the Manufacturing Technology Center, just to explain a little bit about who we are and what we do. Then want to talk about the rationale behind the work that we're doing at the MTC and our objectives within the Co-Versatile project. We do then have a poll that we'd like to encourage everybody to participate in. That'll give us some interesting feedback. And then Anas is going to talk in much more detail about what we're actually doing within the project. If anybody has any questions as we're going through, please don't hesitate to put them in the chat. So the Manufacturing Technology Center is an independent research and technology organization that was originally set up by the UK government just over 10 years ago. It's grown significantly over that time, and we now have about 800 staff working within this organization, and it's certainly the largest research and technology organization within the UK. One of the significant advantages we do have is that we have the ability and the capability to operate some of the most advanced manufacturing equipment that's available within the world. So we're always trying to ensure that our equipment is at the forefront of technology development. And at the same time, we have market leading expertise that allows us to utilize that equipment to develop new manufacturing processes, and most importantly, to ensure that the technologies that we're developed can actually be applied within industry. So we are very much working at showing the art of the possible to manufacturing and helping them to utilize and adopt these technologies that we're bringing forward. If we could have the next slide, please, Anas. So the rationale behind our input to the Coverstile project is really driven by the pandemic and the need for businesses to be able to repurpose and modify their production lines, and also scale them up, ramp them up in particular cases where there is a new or urgent production need that we've never actually had to deal with before. It may be things related to the pandemic, but we're also seeing the need for businesses to become more resilient and potentially to bring in-house the manufacturing of some of the components that they're potentially making that they may have otherwise sourced from overseas. So it is very important that businesses do take advantage of the potential flexibility of their automation solutions to allow them to both ramp them up quickly, but also adapt them to new products and new challenges. So ultimately, we're trying to develop a demonstrator that can show how that can be done to enable a rapid repurposing when it's necessary, ideally within a sort of two-day time frame. So a really fast repurposing of an automation system. If you could give us the next slide, please, Anas. So we decided that we were going to base this work on some equipment that we already had within the Manufacturing Technology Center. It's a system called the Small Component Assembly Loop, or SCALP cell. It was a manufacturing cell that was built. It's actually slightly over 5 years old now, so we've had it a little while. And it was designed to demonstrate how manufacturing systems could be reconfigured in a relatively short time frame. Not anything approaching the 2 days that we're aiming for now, but it was intended to be a flexible system when it was originally built. And although we did achieve some success with that, it is relatively complicated, and that does actually increase the time required to reconfigure it. And I should also add that given that it's 5 years old, the technology within it and the software within it is also obviously 5 years old, and it doesn't necessarily have the flexibility and capability that you can get from current systems. So if we could move on to the next one, please, Anas. So what we're looking to do through the Coverstile project, in collaboration with with two Italian engineering partners, is to actually develop the system so we can enable that rapid reconfigurability by using novel software and hardware solutions to ensure that we can make it as reconfigurable as possible in a very short time frame. And in particular, we'll also be looking at simulation and offline programming to ensure that we can make the best of that capability to reduce the time that's required to do this reconfigurability. So if we could move on to the next one, please, Anas. So at this point, I'd like to raise these two questions, and we very much appreciate your response. So firstly, do we think the flexibility of industrial robots has been exploited effectively? I mean, I remember I've been doing robots a long time. That was always one of the key elements of robot systems. But are we really making the best use of that flexibility? And then the second question really relates to what do we perceive the main challenges are that would enable that flexibility? Is it lack of awareness or expertise? Is it the specialist expertise that might be required? Is it the flexibility around the equipment around the robot that's constraining the robot capability? Or is it the control systems and the incompatibility with other systems that's affecting it? So we'd like your opinions as to what those main barriers are. And the poll is now live, I believe. So hopefully you'll be able to answer those as we continue to talk through the project. I'd like to now hand over to Anas, who will then talk you through more of the detail. Thank you.
Thank you very much, Mike. And I will continue as you mentioned. In the next few slides, I will be talking through some updates on the project progress, and this can be split into two more sections. So we've been working on two main work packages. The first one is the build, measure, learn cycles. The objective is to build minimum viable demonstrator, and the other work package is around the training, coaching, and mentoring. So the technical delivery was part of this work package, which is the build, measure, learn cycles, and it's been just over a year since we started working on co-versatile project back in November 2020, and we still have almost like a year ahead. So for this work package, and in order to track progression in a more agile way, the technical delivery has been divided into 8 cycles in total. Each cycle is 3 months long, and it's split into like 3 phases. Phase number 1 is the build phase, which is 2 months long. This is where we carry out like various technical activities, and then a measure phase will follow after just finishing the build phase for 2 weeks, and this is where we try to review the progress, ensure that it's in line with the overall objective, and then we move to the learn phase, which is again another 2 weeks to record learnings and plan for the next cycle. So this is a way to like monitor and track progress, like better than it's better than like waiting for a year or so in order to see if whether it's aligned with what we required or not. After a year, we've completed 4 cycles. So the main activities we carried out are cell upgrade, use case analysis, O-ring assembly, process analysis, cell modeling, and offline programming. So the first one. So first thing we started with is upgrading the cell, because as Mike mentioned, the original control system used in SculptCell was a little bit out of date. Few connectivity options. So we have discussed the new requirements and proposed like a new system architecture that would be more capable of adding more like connectivity, so the reconfigurability would be easier. So the decision was made to replace the old control system with a new PLC from Siemens, a new S7 1500, along with a new distributed I/O modules to expand the capability of adding more like sensors or actuators if needed. And also the other section is the software upgrade. So we also needed to upgrade the software and pack the new software with the new add-ons as well. So we've managed to install and integrate a robot integrator library package from KUKA, which is called MX Automation. So this kind of add-on piece of software would enable a high-level PLC to control the 2 KUKA robots we have in the cell from a single HMI. And the aim of that is to increase the cell flexibility by enabling a trained operator to add and integrate new robot programs as desired. So this is like this image here shows how the operator can monitor and control a robot from the HMI. So it's now not restricted to only like use the teach pendant to train a robot for new programs. The other activity was about selecting the use case that we will be implemented in the cell, and the chosen use case was the assembly of what's called the CPAP device. So the CPAP device that you can see in the picture is part of it has been used as part of the COVID-19 response. It stands for continuous positive airway pressure. So it's basically it's a medical device that has been used to treat corona patients who suffered from breathing difficulties. So the purpose is to minimize the demand on ventilators. So this part is called the flow generator, the main component of the CPAP device. And we've started analyzing the assembly process and trying to understand what are the involved steps, and then move to like a classifying like the overall steps into two main categories: complex tasks requiring like specialized tools, and the other category for like doing repetitive tasks. And after some discussions and considering what's physically possible to be implemented through SculptCell, we have decided to pick up the most repetitive tasks, which is O-ring insertion. So we have like for each of those parts, like the oxygen inlet, the patient outlet, the other 3 valves controlling the oxygen, for each one of them, we need to insert O-ring. and that has been done manually. So we started thinking how much feasible is it to automate this process using a robot, and how much time we will be saving and making the process more effective. So so this is the use case we selected, the orientation, and after that we moved to like diving further through the O-ring insertion process analysis. So we've explored existing solutions that can handle O-ring fitting process through a robot. So we started looking into like off-shelf O-ring grippers, and we found like many like ready solutions, but there are some limitations. So the current off-shelf grippers, O-ring grippers, can only fit O-rings for parts with very limited depth. So that's why we and for the parts we are using, it's not enough. So we ended up designing our own customized spacers or adapters that would allow this kind of grippers to fit an O-ring in the designated position. So you can see on the image one of the grippers we've down selected. This is from Chonk, and the other two here from Zimmer. And the other thing we also looked at in order to see how we can automate the process is exploring the existing O-ring feeders that can feed like an O-rings to the robot automatically. And after also like having some research and discussions, we couldn't find any off-shelf O-ring feeders that fit for our purpose. So we've come up with a novel prototype design for an automatic O-ring dispenser, which you can see in the next slide. So on the left hand, the image shows the design of the O-ring dispenser prototype, and this is has done internally at MTC, and it's been now like tested, like many iterations has now been implemented and tested. On the right hand side, this image shows the design of the spacers that STAM has been working on, and also we've also manufactured those spacers and tested them. So this is how it should look like when it's ready for handling the O-ring insertion process. The other activity we've been working on parallel is the cell modeling and offline programming. So we aim to shorten the time needed to implement and test desired assembly process. So within MTC, we have the capability to do simulation and offline programming for robots, and we've been using Visual Components software to examine different possibilities to fit or like to do whatever process we'd like to test. And for this, we have used Visual Components to examine different like O-ring fitting scenarios within the cell, using one of those two robots. And this screenshot is taken from Visual Component software, showing the scalp cell without the guards, and showing the gripper mounted. And as I said, this is to allow us to first validate that it's working, and then optimize like the best scenario to do the process. Before committing to any hardware purchase, I guess this is very important idea to add. Like we validated that this is working before committing to any hardware build. So quickly, like the main learnings and results after the first year of the project can be summarized in those points. So we've selected, tested, and purchased a proper O-ring gripper. And we have also managed to design and validate customized gripper adapters to fit our purpose. We've also designed and tested a novel prototype for an O-ring dispenser, like a small compact dispenser. And we have also created offline robot programs on Visual Components software. So we have now verified different scenarios for the assembly process. So as a learning, so these kind of robot simulations results will be converted into cell programming like scenarios or paradigms, so we can speed up the setup of the assembly process. For next year, we have another 4 cycles. So we plan to complete the hardware integration, the gripper and the dispenser into the cell, and start performing the initial experiments for the O-ring insertion process and measure the time needed and how we can maybe optimize the process and learn from what we've done. We also plan to integrate an appropriate vision system. So we would have like maybe another robot with a camera to handle process quality control, so we can make sure that every part has an O-ring on the correct position. We would like also to define another use case, and preferably different to this CPAP assembly one. Then we can analyze the steps required to complete the switchover process to this like new use case, and then perform primary tests to measure the time needed to reconfigure the cell to handle this new use case, and also record the learnings of like what's required to move to this new use case. Last thing we need also to do like over the next year is to do further HMI development to fulfill these simple reconfiguration objectives, because it's always important to allow a trained operator, not like a specialist user, to use the HMI to do the reconfiguration. So it should be intuitive, simple enough to be used by a trained operator. The other work package we've been working on is training, coaching, and mentoring. So the MTC participation is in the project is not about developing or manufacturing like a very specific medical product. We are here to share the knowledge that MTC is building up around the Scalp Robot XL with other manufacturers who are willing to follow the same approach or maybe implement similar robot solutions. So we've been working with our partner HSSMI to design and produce an interactive user guidance, a kind of infographic on best practices to deploy robot systems. And this is the first draft we've come up with. So yeah, the idea is to be easy enough for non-technical persons to follow and understand what's the main requirements. I guess the main objectives is to understand the process of like deploying a robot system in the facility, and maybe ask the right questions when deciding to buy a new robot system. The plans for the next year to continue working on this infographic, to add new content, expand the content, and also extend the guide after like finishing the main steps to deploy like a robot system, to how to fully utilize maybe the flexibility of this robot system. It's not only like deploying, but also benefiting from the flexibility that a robot system can provide. And I will get back to the poll questions to see if we how many results we've received. Can we have maybe some indications?
So thank you, Anas. Thank you, Mike, for the fascinating presentation and sharing the insights. Quite curious to see how you proceed the next year. Regarding the polls, I'm looking at our chat. So we have an overwhelming majority of the audience saying that the robots, the flexibility of industrial robots has not been exploited till now. So which I guess is similar to your proposition. And for the second question, it's quite mixed, I would say. It's I would say a divided audience right now, but we could take that in the next discussion when we would have the panel. Really appreciate your time and also the presentation. I had one quick question to you. Because human-machine collaboration, Industry 4.0, automation, there are these big buzzwords coming in. And it was there before the pandemic as well. So what has changed?
Would like to take it, Mike, or shall I answer that? You're on mute, sorry.
Yeah, sorry. I'll give you a brief answer. I think you're right. A lot of the buzzwords were there, but maybe not the incentive to actually implement the solutions. And I think I think the poll to some extent reflects that, because a lot of people are saying we haven't really used the flexibility that robots can give us. And I think what the pandemic has done has really demonstrated the fact that we need to start utilizing this flexibility so that we can reconfigure these robot systems as much more quickly than we currently do. So I think it's provided the driver, if you like, for people to start using some of the technologies that are available.
Yep, thank you. Very comprehensive. Yeah, so we really appreciate the colleagues from MTC for the presentation. Feel free to check their website, reach out to them and chat for the questions. And now I would like to invite all the speakers for today to have a quick Q&A or a panel discussion. We would also use the opportunity to answer the questions asked in the chat today. So I'd like to invite Matthias on stage, and Cristobal, and our colleagues from DEMCON, Thijs, and Ben. So we have Sylvia on stage as well. Perfect. And I hear a bell, which is that we are at 12. So thank you very much. It was really interesting to see the different topics being addressed today. And for me, the highlight was the ramp up of and also the modifying of production process. So I would like to start with the first, maybe a generic question. What lessons have you learned from the pandemic, and what is your say key takeaway from the pandemic in your I would say in your current projects, for example, Coversatile and also other projects? So what has been the key takeaway for you from the pandemic? So we can start. I see, if I look at clockwise, I see Anas. So maybe Anas, you could start.
Yes, I will speak from like automation system perspective. So yeah, previously, not all of the like features of an automation systems were utilized, and that's, I would say, mainly because there was no incentive, as Mike mentioned, to utilize the full flexibility of an automation system. That would require a little bit like an effort from a specialist person to be involved and to add this, to understand the requirements, and to maybe explain the art of possible to the customer in order to like gain the knowledge that it's possible to integrate with like third party, for example, software, and then justify the business need behind this, I guess. So I guess what we've learned is we need now more to utilize this, because it's required. It's not something we don't have, or there's no like requirement to do this. Now it's more frequent than before that. You will suddenly need to change from producing A to product B quickly enough to respond to the demand. So utilizing these features are now a necessity rather than just like good to have.
Yep. Thank you, Anas. Maybe I'd ask Yuval the same question. Yuval, maybe what has been the key takeaway for you?
Well, as I've mentioned before, as manufacturers, we are quite accustomed to working in emergency conditions, especially for the defense. However, in this scenario where we had to react quite fast, we had to see how we allocate forces into a field which was quite new for us. And for us, working with a group of experts in our manufacturing settings, on the one hand with the mold makers, and on the other hand with the universities, and of course with ML, that they have given us all the technical support for the texturing, it was quite amazing, because in quite a short time, in just a few build measure trial cycles, we've managed to come up with a functional mask. So I think that a teamwork and the distance was not an issue. In spite of all the limitation, the distance was not an issue. In regular projects, we physically meet. In this project, we only met through Zoom, and we've managed to practice and to cooperate and to work together and to come up with a functional product. I think that the lesson that we should take into this from this pandemic is that, and it's not only us as manufacturers or as research centers, our leaders has to come up with a program that will be like an automatic pilot operating industries to support these things. There were so many limitations, technical limitations like lack of flights. It was hard to get materials. Trucks were not available. Things which you don't think about normally. And they were obstacles in this scenario. Not only here in Israel, but all over the world. And we have to make sure that there's going to be a protocol, which is going to be like a standard protocol, be utilized by many manufacturers. And as I've mentioned, like an autopilot, once the risk is higher and you need, for example, masks like this, so there will be at least a big enough portfolio of manufacturers that can, in a day, shift their machineries from working on nipples, on silicone nipples, and shifting them into silicone masks. So you know that you can allocate machines, know-how, materials, etc. And the only thing that you have to make sure that you have ready in those places is the specific tools for the mask. For mold, it's quite easily to shift between different parts, between silicone O-ring or a silicone mask. It's just a modification on the machine, but you need to have the tool. You need to have the knowledge of how it is going to look like, and this is something that we have to create a way to bring or to educate our leaders to make sure that lots of manufacturers will be there at time of needs. Will be there and will be committed to manufacturing. We were committed because, as I've mentioned, we are a vital factory during emergency periods, so we are committed. But we're not committed to manufacturing masks. So we had to put ourselves in a position that we took this commitment upon ourselves. And we did it internally, and we did it within the group, within the Versatile group. And I think that it should come from a higher level. To create this kind of structure that manufacturers would know that in pandemic, they have to allocate their resources, both machines, materials, and manwork, team force, engineering, in order to come up with solutions.
Yeah. Very, very good, Yuval. I think you hit the nail basically about international collaboration coming together from a policy perspective and also this standard operating procedure for future crises. So it's definitely rings a bell. I would like to maybe ask Thais a little bit, maybe a reformulated question. You had Ben also talking about the purpose, and the key takeaways was that how we could have more open communication in the organization. In your presentation, you had this one slide about there is a lot of information on the internet. Would you say open source? So internet is also coming from this open source, I would say, revolution. Would you say open source is here to stay and would be developing further?
Yeah, so it's kind of in our culture, in our organization as well, to have a very open door policy between engineers that have extra experience in some fields. So we strongly believe that cooperation works, and that we should share our knowledge to get to a next level on specific technologies that we need to develop, also for the big societal questions. So for the big challenges that we face as humanity. Yeah, and I think that definitely, of course, the internet is one big open source. It also contains a lot of information nowadays that you cannot trust. So there's also a challenge there, I think, to know where these sources come from and that you can verify them. So as also said, not take anything for granted that you might find, but still make up your mind yourself about the direction you want to go and decisions to be made. So I think there is definitely the internet is giving a lot of opportunities to share and to learn from, but we always have to be skeptic about what we take on for granted and what we still need to develop ourselves, or what we come up with.
Yeah, indeed. So yeah, be careful what's on the internet, but at the same time, it's really helpful.
We did get the opportunity to learn a lot while we were in a kind of situation where we want to get more to know about what does it mean to make face masks, what does it mean to work on that technology. So you start digging, and typically you would start on the internet finding a lot of points that attach to this topic and where you can learn from, but still we really went our own way at developing our technology.
Yep, thanks. And I'd like to bring in Sylvia here from a communications perspective. The pandemic has highlighted the importance of communication and also, I would say, misinformation. From your perspective, what is the key takeaway from a communications perspective of the pandemic?
We learned how bad fake news can be. So communication experts, journalists have to be extremely careful, because once you give a news spreads. Of course, you can create panic, or you can create damages giving the wrong informations with the wrong sources. So working in this field, I find myself as a person and as a professional extremely committed and responsible for the information that I share. And I think that this is a reflection that everyone that works in communication has to do while discussing those matters. Yes.
Mm-hmm. Yep. Thank you, Sylvia. I'd like to bring in Matthias from a technology transfer and a research perspective. You had this project with the silicon reuse of silicon masks. Has the pandemic changed the way technology transfer is happening from industry, or say from academia to industry?
So from my perspective, from my experience, what has changed in academics is that we have to speeden up processes, and the main difference now is that we do a really application-oriented research. So basic research, of course, is important, but it went into the background during the pandemic, and we really worked on products and on processes to create these products to be as responsive as possible. And this has changed, at least in engineering disciplines.
Yep, thank you. So more focus on applied research closer to challenges.
Yep. Exactly.
Thank you, Matthias. Christopher, maybe the quick question to you regarding the key takeaway for your company and what you are planning for the rest of the project now until next year. So you could ask Sergio or Cristobal. You could answer that. So Cristobal, the question was, what's the key takeaway for you? Say lessons learned from the pandemic for your company, and how do you implement that in the next year? Okay, Cristobal, can you maybe quickly check if we cannot hear you right now?
Oh, okay. Yes, I can't hear you well, Amardeep.
Okay, no problem. So I think Cristobal had a very interesting video and a presentation as well about the disinfection sprays. And for me, what caught the eye was this benchmarking and the difference between the traditional electromagnetic sprayer and the one they developed. So I'm quite curious to see how that product develops further. We are short of time, but I would take the opportunity to maybe ask one more question, open question. We talk a lot about future of manufacturing, Vision 2030, and nobody could predict the pandemic, or very few of the experts could predict. Now looking ahead, so there's one takeaway for me, definitely resilience, reconfigurability, automation, reshoring is important, but what can we learn can we learn in terms of prediction of the future or preparing ourselves for the future? Do we need to think maybe a little bit more in short term or mid term, or be more agile with the tools you mentioned? So it's an open question to the panel. Feel free to jump in, and yeah. Maybe Anas, you had this build, measure, life cycle. So what's your take?
Yes, for us, and again from like automation system perspective, I would say spreading the knowledge, because I've had a chance to see like the results from the poll, and 80% of people who responded thinks that lack of knowledge is the reason why the flexibility of industrial automation systems are not flexible. So I guess spreading the knowledge around what's possible and why it's important, and I guess highlight the business benefits like behind spending like a little bit more cost in order to allow this and enable the flexibility is now more important. So I guess we will be working not only in Coversità but with other projects in order to spread the word, educate, I would say, like small manufacturers as well, that this is possible, this is what you need to think about, this is important. Keep an eye on like something unexpected in the future, so that you will be half ready at least to respond to whatever situation comes.
Yeah. Okay. Perfect. So spreading the word, be half ready at least. So I take that. Yeah, this is a food for thought for all the panelists. Maybe if you can think over it the next weeks. And I really like to thank the panelists, Anas, Matthias, Christopher, Yuval, Sylvia, Thais, and Ben. Really appreciate your contribution today, and I wish you all the best with the project. We have one more year to go, and yeah, thank you.
Thank you very much.
Thank you
Thank
very
you
much.
all for hosting.
Thank you.
Everybody.
Thank you very much, everybody.
So that was a very interesting panel. A quick reminder, the session is recorded. You could look at the recordings, which will be available by the end of business or maybe early tomorrow. Quick heads up, we have one more webinar to go, which is on 9th of December. We will talk about workforce ramp up, and we would have 3 speakers for that one. So please bookmark your calendars for it, and feel free to see the recording later on. And yes, indeed. So we, as mentioned earlier, this is a project which continues until next year. We have the big matchathon being planned in spring 2022, and there is a series of webinars also being planned to disseminate the results and also to talk about the progress of the project. Feel free to check our website, that social media channels, LinkedIn and Twitter, and follow us, like, comment, and thank you for the contribution today. Thank you for being part of the webinar, and we stay in touch.